Okay, welcome everybody. Here is the review for the second exam. I'm going to go through this kind of quickly because you've got the option to stop and rewind and things like that. So I'm going to kind of go through this at a pretty good clip. So a couple of things that we started out with was we started talking about the imaginary numbers, right? And the imaginary numbers gave us a way to talk about square roots of negative numbers. So we said that initially that the number I is the square root of negative 1, which means that I squared is negative 1. Right, and this is something that's pretty important through this section. So what I can do with the square root of negative 25 is I could rewrite it as the square root of 25 times the square root of negative 1. Okay, because negative 1 times 25 is negative 25. So this is going to give me 5 and then I. Okay, and then for this next one, I can rewrite each one of these, and I can say that this is the square root of negative 1 times square root of 3. So the square root of negative 3 could be written as I times the square root of 3. Okay, and then we can multiply that by I times the square root of 12. All right, so when I multiply these together, this I and I are going to get multiplied together to give me I squared. And this square root of 3 and the square root of 12 is the same thing as the square root of 3 times 12 is 36. All right, so this square root of 36 is going to give me 6, and I squared is negative 1, so my answer will be negative 6. Right, and then multiplying two complex numbers together where they have real and imaginary parts, this is just going to be like foiling. So the first times the first is going to give me 2. The outsides will give me negative 3i. The insides will give me plus 2i. And the last times the last is going to give me minus 3i squared. All right, so this I squared is negative 1, so this is the same thing as plus 3. And 3 and 2 is 5. And then negative 3i plus 2i is negative I. Okay? This one, we've got this I on the outside, and then we're going to multiply that by the square root of negative 49. So the square root of 49 is 7, and so if we pull out that negative 1, we're going to end up with I times the square root of 49 is 7. So this gives me I squared times 7. Remember, I squared is negative 1, so this is just negative 7. Right? And then squaring a complex number is the same thing as multiplying by itself. Okay, we can't just square both the terms on the inside. We have to write it out like this and then FOIL. So the first times the first is 1. The insides and outsides are both going to be 2i. And the last times the last is going to give me plus 4i squared. Okay, so 4i squared is the same thing as negative 4 plus 1 is negative 3, and then 2i and 2i is 4i. All right, this one is going to be very similar. We're going to take 2 plus I root 5 times 2 plus I root 5. First times the first is going to give me 4. The outsides are going to give me 2i root 5. The insides are going to also give me 2i root 5. And then the last times the last is going to give me radical 5 times radical 5 is plus 5. And then I times I is I squared. All right, so when I simplify this, this is going to give me 5 times negative 1 is negative 5 plus 4 is negative 1. And then these two I can combine to give me plus 4i root 5. Okay, and then we never really talked too much about what happens if we take I and raise it to higher powers. But if you think about what I to the sixth means, it means take I times I times I times I times I times I 6 times. All right, so if I multiply these two together, that's going to give me I squared. These two are going to give me another I squared, and these are going to give me another I squared. Okay, each one of these I squareds is negative 1, so it's going to give me negative 1 times negative 1 times negative 1, and then negative 1 times negative 1 times negative 1 is negative 1. Okay, and then we had these problems where we ended up with a complex number divided by another complex number, and the key was to get rid of the I in the denominator. And one of the things we talked a little bit about was the complex conjugate. So this says 3 plus I on the bottom, so to get rid of the I there, I'm going to multiply by its conjugate, and then I'm going to multiply the numerator also by its conjugate. All right, so I'm going to FOIL both of these. So in the numerator, first times the first is going to give me 3. The outsides are going to give me negative I. The insides give me plus 6I. And the last times the last gives me minus 2I squared. And then in the bottom I get first times the first is 9. The outsides are going to give me minus 3I. The insides give me plus 3I, right? And this is why we multiply by the complex conjugate, because we'll get these to cancel out. And then I'm going to have I times negative I is negative I squared. All right, so in the numerator, this is the same thing as minus negative 2, so that's plus 2. So that'll be 5, and these two together will give me plus 5I. And then in the denominator, I squared is negative 1, so negative I squared would be negative negative 1, okay, is positive 1, plus 9 is 10. Right, and then if I want to take this one step further, I could say that this is the same thing as 5 over 10 plus 5 over 10 times I, and then I could reduce this to 1/2 plus 1/2 I. Okay, so we took this complex number that was written as a quotient and we wrote it as a standard form. Okay, one of the things that you should definitely have written down on your formula sheet is the quadratic formula. And the quadratic formula says that x will be equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay, now we could solve some of these by factoring, and some of them I don't think we can factor. This one I think I can factor, and the factors are going to be 2 factors of negative 12 that add up to 4. So my choices are 1 and 12, 6 and 2, and 3 and 4. And if I have 6 and 2, I can get 4 by putting a 6 and a 2 in here. And I want to get a positive 6 and a minus 2. And then you can double check to make sure that when you FOIL that, you're going to get the quadratic that you have up above. So what's going to make this equal to 0? It's when x plus 6 is equal to 0 or x is negative 6. And this is going to be equal to 0 when x is equal to 2. Okay? We could have done that one with the quadratic formula, but we could also factor it. Okay, I'm going to do these other ones using the quadratic formula. So this one I can't factor because there are no factors of 2 that add up to 4. So I'm going to use the quadratic formula on this one and say x is equal to negative b is negative 4 plus or minus the square root of b squared is 16 minus 4 times 1 times 2, and then all of that divided by 2. All right, so negative 4 plus or minus the square root. 16 minus 8 is 8 divided by 2. Okay, so I get negative 4, and then plus or minus. I'm going to think of this 8 as the square root of 4 times the square root of 2. The square root of 4 is 2 times root 2, all divided by 2. Okay, this is going to give me negative 4 divided by 2 is negative 2, and then 2 divided by 2 is going to give me plus or minus just the square root of 2. Okay, so two different answers on that one. Negative 2 plus root 2 and negative 2 minus root 2. Okay, and this here where it says give exact answers, okay, that means give your answer like this. Give it as a radical. Okay, don't try to write it as a decimal. Okay, and then if we do the same thing on this one, there are no factors of 5 that are going to add up to negative 4 because the two signs have to be the same. I can get 5 and 1, but they have to both be positive or both negative, and I can't get negative 4 from that. So I'm going to use the quadratic formula again, and I'm going to get x is negative b would be negative negative 4 is positive 4, plus or minus the square root of 16 minus 4 times 1 times 5, all divided by 2. All right, so we get 4 plus or minus 16 minus 20 is negative 4. And the square root of negative 4 is 2i, all divided by 2. 4 divided by 2 is 2. 2 divided by 2 is, it's going to give me 1i. Okay, so make sure that you have the quadratic formula either memorized or written down on your formula sheet. Okay, the next questions are find the vertex and give the range of each of the following. Okay, now we could do this one two different ways. One way we could do this is we could use the fact that I know that the vertex is going to have an x-coordinate that is negative b divided by 2a. Okay, that might be useful to have on your formula sheet as well. And then we could also write the equation in vertex form. And in vertex form, we're going to write it as y equals a times x minus h squared plus k. And then the vertex of this is going to come out of that equation pretty easily. It's just going to be hk. Okay, so I want to do the first one both ways. And then I think the other ones I want to do by converting to the vertex form. Okay, I'll tell you that one of the questions on the exam is going to say write it in vertex form. Okay, so for this one, let's do this one with x is equal to negative b would be negative 6 divided by 2a is 2 times 1. So we're going to get an x-coordinate that's negative 3. So to find the vertex of this parabola, it'll be negative 3, and then if I plug negative 3 into this equation, we're going to get negative 3 squared plus 6 times negative 3 plus 4. So that's going to give me 9 minus 18 is negative 9 plus 4 is negative 5. Okay, so this is the vertex. And then it says give the range of each of the following. All right, so I know that the vertex is negative 3, negative 5. And I also know that the parabola is going to open upward because the leading coefficient is positive. All right, so this point here is the point negative 3, negative 5. And so the range would be from this value upward. All right, so the range is going to be from negative 5 to infinity. Okay, and this actually should be a square bracket. Okay, so everything from negative 5 upward. Okay, now if I had done this one by putting it in vertex form, all right, let me, I'm going to do that over here. So to put this in vertex form, we want to write this in this form up here. Okay, the leading coefficient is already 1, so I don't really have to do anything with the a. So I want to take this x squared plus 6x. All right, and remember that we're going to add something in here to make this a perfect square. Right, and then plus 4. All right, so to find the number that goes in here, we're going to write this as x plus 3. We take half of this number, and then if I square this, I'm going to get the first times the first is x squared. The insides and outsides are going to be 3x and 3x. Gives me 6x. And then the last times the last gives me 9. All right, and then what we need to do is if we add 9 here, we're going to subtract 9 here. All right, and so our vertex form of the parabola is going to be y equals x plus 3 quantity squared, and then plus negative 5. Okay, and then if you go back to the vertex form of the parabola, it looks like this now, and the vertex is the opposite of this number and this number. Okay, so we end up with negative 3, negative 5 either way. Okay, so I think that the vertex form is a little bit more difficult, so let me do the vertex form on this one as well. And I want to look at this because there's a leading coefficient that is not 1. So I'm going to take out a negative 2, and I'm going to be left with x squared. And if I take a negative 2 out of here, I'm going to be left with negative 3x, and then minus 7. Okay, so we get negative 2, then I've got x squared minus 3x, and then I want to add something here to make that a perfect square, and then I'm going to subtract that same number. All right, so to find the number that goes here, I take half of this number. Half of that number is negative 3 over 2, and then I'm going to square it. All right, so when I square that, I'm going to get 9 over 4. Okay, so far I have negative 2 times this is going to be x minus 3 halves squared. All right, and then when I put this 9 over 4 in here, I also have to remember that I'm going to multiply that by negative 2. So if I multiply those together, I'm still going to get this negative 7, but then I also have to subtract the value that I'm adding. All right, so I'm adding negative 2 times 9 over 4. That 2 and that 4 will reduce, and that's going to give me minus 9 over 2. Okay? So this is the same thing as writing negative 2 times x minus 3 halves squared, and then negative 7 minus 9 halves. I could think of this as negative 14 over 2 and negative 9 over 2. Negative 14 over 2 minus 9 over 2. Add these together, you're going to get 23 over the common denominator of 2, and this will be minus. Okay, so this is the vertex form of this parabola. The vertex is going to be at 3 halves and negative 23 halves. And this parabola is going to open downward. Right? So I didn't leave myself a lot of room here. But the vertex is minus 3 halves and minus 23 halves. And the parabola goes like this. So this y value is negative 23 halves, so the range would be from negative infinity up to negative 23 halves, and a square bracket there. Okay, so to be from negative 23 halves and then everything from that down. Okay, so that one's a little bit more challenging, and it's mostly challenging because we end up with a fraction in there because this is an odd number. Okay, this one is a little bit easier, but the first thing I'm going to do is factor out this leading coefficient, which is negative 1, and I'll be left with x squared and plus 8x. Okay, and then plus 2. All right, so I want to think about the same thing. What am I going to add here to make this a perfect square? So we take half of 8, and then when I square this, I'm going to get first times the first is x squared. Insides and outsides are going to add up to 8x, and the last term here is going to be 16. Okay, so if I add a 16 in here, but then I got to remember I'm multiplying that by a negative 1, so it's actually subtracting 16. So I want to add another 16 over here. Okay, so if I think about what this graph looks like, it's going to open downward because of this negative. The vertex is going to be at negative 4, 16. So the range on this one is going to be from negative infinity to 16, square bracket and a round bracket. Okay, so everything from 16 down. Okay, and then this one, let's do this one really quickly. So we're going to end up with this is x minus 1/2. Okay, let's see, I want to do this with another step in between. Okay, so this is going to be x squared minus x, and then we want to add something in here to make that a perfect square, and then we've still got the plus 5, and then we're going to also make an adjustment. All right, so we take half of this middle coefficient, so this will be x minus 1/2. When I square that, I'm going to get, first times the first is okay, the insides and outsides are both going to be negative 1/2 x, and then I'm going to square this to get 1/4. All right, now I didn't have to factor out a leading coefficient here, so we're adding 1/4, so we're also going to subtract 1/4. All right, so we're going to end up with 5 minus 1/4 is 20/4 minus 1/4 is plus 19 over 4. This parabola is going to open upward, and the vertex is going to be at 1/2 and 19 over 4. Right, and because this parabola opens upward, the range is going to be from 19 over 4 to infinity. Okay, so know how to find the vertex using this formula when the equation is written in standard form. Sometimes this might be easier. And then also know how to convert it into the vertex form of a parabola. Right, and writing the vertex form of the parabola is beneficial because then we can pick out the vertex from the equation. Okay, then there's an application problem with revenue. Okay, so revenue from selling X flash drives can be modeled by R equals X times 8 minus 0.05X. Right, and what this represents is this number is the number of items sold. And this expression here is the price per item. All right, so if you take the number of items that you sell and you multiply by the price per item, that's going to give you the money that you're going to bring in. Okay, so if I wanted to know what is the revenue of selling 20 flash drives, that's a simple question. That's just plug 20 into the equation. So we get 20 times 8 minus 0.05 times 20. So we get 20 multiplied by 8 minus 0.05 times 20. That is 1. And so we get 20 times 7 is 140. Okay, so what this represents is if I sold 20 flash drives, my revenue is going to be $140. Okay, now what this expression up here might represent is if you sell 0 items, you can sell them for $8 each, but if you decrease the price, you're going to increase the number of items sold. So there's kind of a give and take. The price is going to go down, but the number of items goes up. And then we would like to be able to find how many flash drives would we have to sell in order to maximize our revenue. All right, so if you think about what the graph of this function looks like, it is the same thing as writing r of x is equal to 8x, I'm going to just multiply this out, minus 0.05x squared. Okay, now if I were to graph this function is going to look something like this. Okay, it's going to open downward because this is the leading coefficient. It's the coefficient that's attached to the x squared, and it's negative, so it goes downward. So to find the number of flash drives, all I really have to do is find out what is the x coordinate of this point. All right, so the x coordinate is going to be negative b divided by 2a. So negative b would be negative 8 divided by 2 times negative 0.05. So we're going to get negative 8 divided by 2 times 0.05 is going to give me negative 0.10. Right, and then negative 8 divided by 0.1 gives me 80. Okay, so I should sell 80 flash drives in order to maximize my profit. Okay, and then if I maximize my profit when x is equal to 80, then this answer should be just what is R of 80. All right, so I'm just going to plug 80 into the function. So it'll be 80 times 8 minus 0.05 times 80. So that gives me 80 times 8 minus 0.05 times 80 is 4. So I get 80 times 4 is 320. Okay, so if I sell 80 flash drives, I'm going to make $320 in revenue. Okay, so this is just an application of, why are we interested in the vertex? Okay, because the vertex is a lot of times either the highest point or the lowest point on the graph. Okay, and then it makes it kind of nice to be able to sorry, I've got group text I'm in. Okay, so let's move on then. Okay, the next problem, okay, and I'm going to scan these so that you guys will have access to the scans as well. All right, so this one is sketch the solution set. Okay, and we did this on Tuesday, and what we wanted to do is find out where is this equal to 0, and this is going to be equal to 0 when x is 3 or negative 2. All right, so I'm going to plot a point at negative 2, and I'm going to plot a point at 3. And then the process that I told you was, let's just pick the different intervals and see if the function is positive or negative on the intervals. So if I pick a number over here, like let's say negative 5, negative 5 minus 3 is going to give me a negative number. And negative 5 plus 2 is also going to give me a negative number. And a negative times a negative is going to give me a positive result over here. All right, then if I pick a number in between, like 0, 0 minus 3 is negative, but 0 plus 2 is positive. A negative times a positive is going to give me negative. And then if I pick a number that's bigger than 3, like 6 or 7, 6 or 7 minus 3 is a positive number. 6 or 7 plus 2 is also positive. So the function will be positive over here. And then the question is asking, where is this negative? And it is negative in between. Okay? And then if this asks you to give the interval would be from negative 2 to 3, and then not including the two endpoints. All right, remember, if this includes equal to, then we fill in the circles and we make these square brackets. Okay, so let's do the same thing on this one. This one is going to have a 0 at positive 1 and also at negative 3. All right, and then we're going to do the same thing. Pick a number that's in this interval over here, like negative 5. Negative 5 minus 1 is negative. And then negative 5 plus 3 is negative 2, but when I square that, I'm going to get a positive result. Okay, so a negative times a positive is going to give me negative over here. Pick a number in between, like let's say negative 2. Negative 2 minus 1 is still negative. Negative 2 plus 3 is positive, and then square it and I've still got positive. So this is going to be negative still here. Right? And usually this doesn't happen where the sign doesn't change, but the reason that the sign doesn't change is because of the square there. Okay, remember this one has a double 0 at negative 3. All right, and then if I pick any number that is bigger than 3 out here, then this is going to be bigger than 1. This will be positive and this will be positive squared, and we'll get positive over here. All right, so this says greater than 0, so my solution is going to be everything where the function is positive. Okay, and again, if this said equal to as well, then we'd fill in this circle, and we'd also fill in this circle. Okay, we'd fill in both circles if this was equal to. Okay, and then for this one, we've got to work a little bit harder and factor this. So the factors of -4 that add up to 3 would be +4 and -1. And we want to know where this is positive. So this is going to be at -4 and at 1. All right, and then if we go through the same process, I'm going to tell you that you're going to get positive over here, we're going to get negative in between, and we're going to get positive over here. Okay, you can check that and pick some numbers in those intervals and just see what happens. And then we want to know, where is this going to be greater than 0? So greater than 0 would be out here or over here. Okay, and then the next, that's more or less the stuff that we did in chapter 3. And then in chapter 4 we got into the synthetic division stuff. So if I divide this, I'm going to write down the coefficients are 1, -2, -5, and 6. And remember that if I'm dividing by x minus 2, I put a positive 2 on the outside. All right, and then the process was bring down the 1, multiply by 2, add, and I get 0. Times 2 is still 0. And we get -5, and then we get -10, and we get -4. All right, and then the problem says to give the quotient and the remainder. All right, so the remainder is easy. The remainder is just going to be this number here, -4. Okay, and then the quotient is going to come from this here, right? And we got to remember that a couple things we could do here. If I divide a third degree by a first degree, I'm going to end up with a second degree polynomial here. Or you can just kind of count backwards and say this is the constant, this is the x term, and this is the x squared. So the quotient will be x squared plus 0x minus 5. Okay, so the quotient and the remainder. Okay, and then is x minus 2 a factor of this function? The answer would be no. And the reason is the remainder is not equal to 0. Okay, the remainder is not equal to 0. All right, so then we want to show that this is a factor of f of x. All right, so I'm going to put 3 on the outside, and then my coefficients are still 1, -2, -5, and 6. Bring down the 1, okay, and I'm expecting to get a 0 over here. Is multiply and I get 3, add and I get 1, multiply and I get 3, add and I get -2, multiply and I get -6, and I'm right, I do get 0. All right, and then it says to factor this completely. So to factor it completely, I know that x minus 3 is one factor, and the other factor is going to come from these coefficients, and this will be a quadratic, x squared plus x minus 2. And then if I factor this further, I'm going to get x minus 3, and then the factors of this are going to be x and x. The factors of -2 that add up to +1 would be +2 and -1. Okay, and then make sure that we answer the question that was asked. This one says to factor completely. These are the 3 factors. All right, and then find all the zeros. So then I would just want to set this function equal to 0, and you're going to find that that's going to happen when x is 3, or -2, or +1. Okay, we did several problems like that. That's kind of typical of the kinds of questions I want to have you do. Okay, and then the next set of problems is find a polynomial with real coefficients whose zeros are the given numbers. So this one says a polynomial of degree 3, and these are the zeros. So this is going to be kind of the opposite of factoring. If I know that these are zeros, then I know that there's going to be a factor of x minus 2, there's going to be a factor of x minus 3, and there's going to be a factor of x plus 2. Okay, so this is the function, is what I get when I multiply all this out. Okay, and it seemed like you guys like to use that table to find these products. So I'm going to multiply these two together first. And when I multiply those two together, I'm going to get first times the first is x squared. The outsides are going to give me negative 3x, and the insides are going to give me negative 2x, so it'll be negative 5x. And then negative 2 times negative 3 is plus 6. Okay, and then I'm going to multiply that by x plus 2. All right, so when I multiply this, I'm going to get x to the third minus 5x squared plus 6x, and I'm going to get 2x squared minus 10x and plus 12. All right, so when I combine all the terms here, I'm going to get x to the third and then minus 5x squared, and 2x squared is going to give me minus 3x squared, and then minus 4x and plus 12. Okay, the next one, same kind of problem. We can write this as x minus root 2, x plus root 2, and x minus 4. All right, and then if I multiply these two together, I'm going to get x times x is x squared. And then the insides and the outsides are going to cancel each other out. Okay, I'm going to get minus radical 2x and positive radical 2x, and those are going to cancel. And then the last times the last is going to be negative. Square root of 2 times square root of 2 is plain 2. All right, this is going to get multiplied by x minus 4. All right, so I end up with just a 2 by 2 matrix here. These two are going to give me x to the third minus 2x minus 4x squared and plus 8. All right, so the polynomial will be x to the third minus 4x squared minus 2x and plus 8. Okay, and then this one says a polynomial of degree 3. One of the things that I should know is that if 2 plus I is a 0, then 2 minus I is also a 0. All right, this one's going to be a little bit more work. I'm going to have to take x minus 2 plus I times x minus 2 minus I. That's going to give me the factors for these two, and then that's going to get multiplied by x minus 3. All right, and then I've got to multiply all this together. This is going to be easiest, I think, if I write this as x minus 2 minus I, and I've just distributed that negative sign. And then this will be x minus 2 plus I, and then times x minus 3. All right, so I'm going to multiply these two together first. All right, and when I do that, I'm going to take advantage of the matrix again. So I'm going to say x minus 2 minus I, and then x minus 2 plus I. All right, this is going to give me a 3 by 3. All right, these two are going to give me x squared minus 2x minus ix. This will give me minus 2x. This will give me 4. This will be plus 2i. This one will be ix. This will be negative 2i, and this will be negative I squared. Okay, so I've got an x squared. I've got a minus 2x. And then this and this are going to cancel. This and this will cancel. And I'm going to be left with 4 and negative I squared. Negative I squared is the same thing as negative negative 1, or plus 1, and then plus 4 is plus 5. Okay, so that's what I get when I multiply these two together, and then I'm going to multiply that by x minus 3. And I really find that if you use the table like this, you'll make fewer mistakes. All right, so this will be x to the third minus 2x squared plus 5x minus 3x squared plus 6x and minus 15. Okay, so this will be x to the third. These two are going to give me minus 5x squared. These two give me plus 11x and minus 15. Okay, so this would be the polynomial that has these three zeros. Okay, then this one says a polynomial of degree 4, and I've got these two zeros. So I also know that 2 plus I is going to be a 0, and I also know that negative 3i is going to be another 0. Okay, sorry, this should be minus. Okay, so my factors then are going to be x minus, let's do this one first, 2 plus I, times x minus 2 minus I, and then we're going to get an x minus 3i and an x plus 3i. Okay, now these two together, we've already done all that work over here, and that was this polynomial here. So these two together are going to give me x squared minus 2x plus 5. Okay, we're going to do exactly the work I did over here. And then when I multiply these two together, I think I could probably just FOIL these. First times the first is going to give me x squared. The insides and the outsides are going to cancel out, and I'm going to be left with negative 3i times 3i will give me negative 9i squared. And then remember, I squared is negative 1 times negative 9 will give me plus 9. All right, so then if I use the table again, this will be x to the fourth minus 2x cubed plus 5x squared, 9x squared minus 18x and 45. Okay, so my answer then will be x to the fourth. This is the only x to the third in there. And then 5x squared and 9x squared will give me plus 14x squared minus 18x plus 45. Okay, so these problems are a little bit more of a challenge, but all we have to do is multiply out the corresponding factors with the corresponding given zeros. Okay, next problem. Suppose we've got this fourth degree polynomial. Right, now I should recognize that this is a fourth degree polynomial because we have 3 bends. Okay, remember that the number of bends or the number of turning points is 1 less than the degree. Okay, and then also we could look at this and say this graph crosses the x-axis in 4 places, so it could be a fourth degree polynomial. All right, so we're given this information. And then the question is, how many real zeros does f of x have? Well, if we didn't have the graph, we could say that f of x could have 4 real zeros. Okay, and it could also have 2 real zeros, or it could have no real zeros. All right, and the reason it's going to have 4, 2, or 0 is because if there are imaginary ones, they have to come in pairs. Okay, so 4 or 2 or 0 real zeros. I can tell from the graph that there's actually going to be 4. Okay. How many imaginary zeros? Well, if there's 4 zeros altogether and 4 of them are real, that means that there are no imaginary ones. Okay, and then we want to find the zeros of f of x. Okay, so again, if we didn't have the graph, we could look at what are the possible rational zeros? Okay, so remember p is the factors of the last term, so this would be plus or minus 1, plus or minus 2, and plus or minus 4. And then q would be plus or minus 1 only. All right, so my possible values for p over q would be plus or minus 1, plus or minus 2, and plus or minus 4. All right, now if I look at the graph, it looks like this is going to cross at negative 2. And it looks like this one crosses at 1. All right, so I'm going to take advantage of the graph and say it looks like those are two of the zeros. All right, but I want to verify that they actually are. All right, so I'm going to look at negative 2. So I'm going to put negative 2 on the outside. And I'm going to put the coefficients are 1, 1, negative 4, 13, and 4. All right, and I'm kind of expecting to get 0 here. All right, so bring down the 1 times negative 2, add, multiply, add, multiply, add, and multiply. I think I got a mistake on this problem. Let's see if that's actually the graph. I think I screwed this one up. Okay, let's see if that's actually the graph. So x to the 4th power plus x to the 3rd power minus 4x squared plus 13x plus 4. Okay, so if I graph this in this window, it looks like I can probably go from negative 3 to 3, and I think probably negative 10 to 10 might be reasonable. Oh yeah, I could tell I screwed this one up. All right, so where is the mistake at? Let's see, I think I need to change that function slightly. So hang on 1 second, give me a minute here to figure this one out. So x squared. Okay, so x to the 4th minus x to the 3rd. This should be a minus. And then minus it. Minus 4x squared. And this should be minus 2x. Sorry. And then plus 4. All right, I think that's the right graph. All right, so let's see if I change that. All right, so this is x to the 4th minus x to the 3rd minus 4x squared. This should be minus 2x plus 4. Let's see if that one looks like the graph. Oops, I'm still off a little bit. What did I mess up? All right, I don't know what I screwed up on this one. Um, let's this is not going to work out very nice if I use the function I came up with either. Sorry about that. Let me I think we can answer the same kind of question. I'm going to just let's skip this one. Okay. I made a mistake in this function and I can't figure out like what I did wrong to get this graph. So we'll skip over this one, but the next question is the same kinds of skills. Okay, so I'm not saying that you don't need to know how to do this, but I'm saying that there's a mistake on here and I don't want to take any more time to go through that one. Okay, so for this one, it says list all the possible rational zeros according to the rational zeros theorem. All right, so this is going to be the factors of p would be plus or minus 1 and plus or minus 5. And the numbers that q could be are going to be plus or minus 1 and plus or minus 2. So any factor or any number that can be written as a factor of p divided by a factor of q are going to be possible rational zeros. So we'll take plus or minus 1 divided by plus or minus 1. We'll take 5 divided by 1. And we'll also take 1 divided by 2. And we'll also take 5 divided by 2. Okay, so then they tell us that this is the graph, right? And I should probably double check to make sure that this one is right. I'm hoping it is. So if I go to the graph, clear this one out, this is 2x raised to the third power minus 9x squared plus 14x minus 14x minus 5. Okay, and then let me graph that one. Okay, so it looks like that is the right graph. Okay, it looks like the one in the picture. Okay, so I'm pretty confident that I did that one right. Okay, so list the possible rational zeros. These are all zeros that are possible according to the rational zeros theorem. Okay, how many real zeros does the function have? Right, I only see one real zero. Okay, how many zeros will this have altogether? It's going to have 3, which means that the other 2 have to be imaginary. And then I want to find all the zeros. Okay, so I'm looking at this 0 here and saying, well, if it's rational, it has to be one of the numbers up here. And it looks like that number could be 1/2. All right, so let's double check to make sure, is 1/2 a 0? All right, so I'm going to put 1/2 on the outside. And I'm going to put the coefficients of 2, -9, 14, and -5. And again, I'm expecting to see 0 down here. Okay, so I'm going to bring down the 2, and then I multiply 1/2 times 2 gives me 1. -9 and 1 is -8. Times 1/2 is -4. Add these, I'm going to get 10. Times 1/2 is 5, and they do add up to 0. Okay, so I know that 1/2 is a 0. All right, now I want to find the other ones, and the benefit of doing this is now I know that x minus 1/2 is one of the factors, and the other factor is going to be 2x squared minus 8x plus 10. And then I want to know where else is this going to be equal to 0. All right, well, this is going to be equal to 0 whenever this part is equal to 0. Okay, now I could look at this function and say, well, I've got a common factor of 2, so I could factor a 2 out, and then I've got smaller numbers to work with. And then just find out where this is equal to 0. All right, so if I use the quadratic formula, I'll get x is equal to -b would be 4 plus or minus the square root of b squared. Okay, that's 16 minus 4 times 1 times 5, all divided by 2 times 1. Okay, if you leave the 2 in there, all these numbers are going to be twice as big, and you're going to end up reducing to the same answer. All right, so this is going to give me 4 plus or minus the square root of 16 minus 20 is negative 4 divided by 2. So 4 plus or minus, this is 2i divided by 2. And then 4 divided by 2 is 2, and 2 divided by 2 is 1 times I. Okay, so my 3 zeros are going to be 1/2 and 2 plus I and 2 minus I. All right, and then if we go back and look where these answers right, there is one real zero, it's 1/2, and there's 2 imaginary ones, and there are these 2 complex conjugates. Okay, so again, you can skip over number 8. I screwed up that problem, so I got to make sure that I fix that for next semester. But it works out to be just the same kinds of skills as we had on the last problem. Okay, so I will have office hours on, no, I won't have office hours. I will open up the Zoom meeting sometime between 5:15 and 5:30 so that you guys can get started early if you want to on the exam. Also, if I get there at 5:15, I might be able to answer some questions before the exam starts, and then you guys will have the 2 hours to get the exam finished. Okay, if you have extended time, I will give you extended time after that, and so you can just stick around until your time expires. Okay, so that's it. I'm going to sign off here, and good luck on the test, and I'll see you guys on Thursday.